places that are my spots where I need to have something. I need to have something happening at -5. So for me, that would be right here. I'm just going to highlight it for myself. That's optional, but you can. If you have, you can absolutely do that. And then I have another one at -1. And then I also have one at 3. Okay. All right. So it says I have a hole at x = 5. And that's on my way to an infinite. So what I'm going to do is just draw a graph. It's going to come in, hit this point. It's going to have a hole. It's going to keep going. And when it hits the blue line, it's either going to have to go up to infinity or down. Doesn't matter. I'm going to make it go up. Right at the wall, it needs to go up. It is optional to put a point at a different spot. You don't have to have another point at the -5. That's optional. Okay, and then on the other side of the blue wall, I'm going to have it come down. This is going to come down. It's going to hit this wall. I'm going to have it stop. I guess I'll put an open circle, or I'll put a closed circle. And then I need to have it jump somewhere, up or down. I'm going to have this one jump down and then go that direction. That's just a sample. Like, there's so many different ways. When I was coming around, you had a lot of different ways to do it. This is just one way to approach it. So we talked about graphing a little bit Friday. The last one we're going to do before we hit our piecewise graph is a square root. So take a moment. Let's copy this function down. And let's go ahead and graph. We're going to graph it together. Okay, so this is the first one that has a red light. And what is our red light? Under a square root. So all the functions that we graphed Friday, which, how many did we graph? I think we just did 2. Quadratic and absolute value. Both of those did not have a red light, which means that when I built my table, I can use any number. But this one does have a red light. So the numbers I use to build my table, we're going to set that greater than or equal to 0. When you solve that, we're going to subtract the 4. So x has to be greater than or equal to -4. So my domain is -4 to infinity. So when I'm building my table, you can pick any number, but I have to start at -4. And I have to use numbers bigger than -4. So could I use -5? No. Could I use 0? Yep, you could use 0. Could I use -3? Okay. So you just need to pick some numbers. Now I am going to intentionally pick these numbers. And I don't know if you know why, but you don't have to do that. Okay, I want to be clear. You can choose any number that is greater than -4. Does anyone know why I chose those 4 numbers? All right, well, let's go ahead and type it in your calculators. Let's see what you get. So for the first one, you're going to have 2 times the square root of, and then you're going to put in, well, you really shouldn't be typing it in the calculator, but I know y'all going to do that anyway. But so for the first one, you end up with a 0, right? 2 times 0 minus 3 gives you a -3. So that's my first y value. And then my next one, I'm going to put in a -3. Okay. What is 4 minus 3? 4. So -3 plus 4 is the same as 4 minus 3. What's 4 minus 3? 1. What's the square root of 1? 1. So what we really have here is just 2 times 1 minus 3, which is a -1. Thank you. My brain shut down a little bit. All right, next one. Let's do 2. Square root, I'm going to put in a 0. Plus 4 minus 3. 0 plus 4 is what? 4. What's the square root of 4? 2. So we have 2 times 2 minus 3, which is going to give you a 1. And then lastly, 2 times the square root of 5 plus 4 minus 3. What's 5 plus 4? 9. What's the square root of 9? So we have 2 times 3 minus 6. 2 times 3 is 6, and 6 minus 6 is 0. So the reason why I specifically picked these numbers is because I wanted to try to get perfect squares underneath my radical. Do you have to do that? No. That just means that you'll have a decimal, which is okay. You can get a decimal for your y value. I just didn't want to. So I knew that I wanted to have a perfect square, so I intentionally chose x values that would give me that. So let's go ahead and graph that. So we have a point at -4, -3. And then we have a point at -3, -1. And then 0, 1. Wait, something ain't right. Wait, what is it? The bottom right? 2 times 3 is 6. Well, thank you. I'm like, what? Why is this curving back down? Appreciate y'all. For some reason, I had my insomnia last night. I did not go to bed till 4 o'clock. So, thank you. All right, so now that looks right. Because I was like, why is this going down like a parabola? That doesn't look right. So, it should be a 3. Okay, so now we're cooking. So, this is what it looks like. This is what a graph of a square root looks like. We don't have 2 arrows. It's only, remember, your domain, it starts at -4 and it goes to the right. Now, go ahead, take a moment after you graph it and write your range. What would you put for your range? What's her lowest y value? -3. And then are the numbers getting bigger or smaller? If you look at your chart, I went from -3. Did it go up or down? Up. So your range would be -3 to infinity. Okay, so now we're going to start graphing what we call piecewise functions. Okay, and that's where we get our jump discontinuity. So if you need graph paper, I do have some in the black tray. Since homework 9, since I made that optional, feel free to use it. And let's go ahead and copy this down. We're going to graph 2 different functions now on one coordinate plane. This is called a piecewise. No, we don't have 2 arrows. I did not put an arrow. What is this? Oh,
it's just the line.
Oh, okay. Yes. Is that okay? Yes. All right, so we got 2 different functions. We're going to graph this function, and we're going to graph this function, but we're only going to graph a piece. So I'll give you a minute to copy it down, and then we'll talk about it. Okay, so notice that the break is happening here at 1. So I'm going to draw in an asymptote and kind of split this graph in half. Because that's really, well, not in half, but we're dividing it. So these 2 functions decided that they wanted to play on the same playground, except they were very clear, you have to stay on your side and I'm going to stay on my side. Okay? So the 2x plus 1 is going to happen when x is greater than 1, which means I'm going to graph that over here. This side is where the 2x plus 1 can play. And the absolute value of x is only when x is less than 1. Now notice that they both can't equal 1 because then it wouldn't be a function. So one of them, they did rock, paper, scissors, and one of them said, okay, I got the 1. But only one of them can have it. Only one. Okay, so over here, we have the absolute value of x. All right, so I'm going to go ahead and make my 2 charts. So let's start with the less than. Absolute value of x. So I have to start it at 1. I have to include the 1. This is where kids get confused. Okay, we still have to include it. He's still on the fence. But when I graph it, he's going to have an open point. His first point is open. So I'm going to use 1, and then I need to pick numbers that are less than 1. So can I use 2 and 3 and 4? Yes or no? Can I use 2, 3, and 4? No. I would just go backwards. You don't even need a lot. You just need to kind of know the pattern. So I'm going to use 0, -1, -2. So this is a pretty basic function. Go ahead and take the absolute value of these 4 numbers to get your y. So the absolute value of 1 is 1. The absolute value of 0, 0. The absolute value of -1, +1. And the absolute value of -2, +2. Everything else is a closed point when I graph. Only the first point is open. So I'm going to go ahead and graph this function. So 1, 1, he has an open circle, and then it looks like a V. This is where it's kind of important for you to know the shape. So this is, we graph one of these Friday. So instead of graphing a whole absolute value function, I just graphed a piece of it. That's why it's called a piecewise. I didn't graph the whole thing. I graphed the piece that was less than 1. All right, so then after you do that, you're ready to move on to the right side of the playground. Which is y equals 2x plus 1. We're going to still make a chart. We're still going to start at 1. Can I use the same numbers? Can I use 0, -1, and -2? No. And why not? Because what does this tell me about it? The numbers I choose have to be greater than for her. So I'm just going to go up 2, 3. That's fine. We don't need a lot. So I don't think you all need a calculator for 2 times 1 plus 1. But I know you all think you do. But we're going to take 2 times 1 plus 1, see what we get. 2 times 2 plus 1, see what we get. 2 times 3 plus 1, and see what we get. So I'll give you a moment. Now for her, because she has the equal sign, everything is closed. All of her points are closed. She has no open points. So what would that be? 2 times 1 is 3. 2 times 1 is 2, and then that would be a 5, and then that would be a 7. So 1, 3. This is her. And then you can also use what you know about graphing a line. We know that to graph, this is a straight line. From this point, I'm just going up 2 and to the right 1, up 2 and to the right 1. So for some of these, like when I don't make a T-chart because I know how to graph y equals mx plus b. So I have my starting point. So from here, I'm just really going up 2 and to the right 1, up 2 and to the right 1. But you can also just use your table. And again, this one is only going to the right. And that would be my piecewise. It's 2 different functions on the same graph. They don't get along. They don't cross each other. And that's it. Did you have a question? Yes.
Do we actually need to put the asymptote there? Or is it just like optional for like personal purposes?
So you said, do we have anything with the dot?
Do we have to actually put the asymptote there?
No. You do not need to draw in this blue line. That's optional. I just wanted you all to realize, like, this is where we're splitting the playground. Any questions? Yes. All right, let's go ahead and do another one. 2 different ones, playing on the same one, but now our fence is at, where am I putting my fence? At 2. So take a moment.
Thank you.
Here you go. Okay, so it's optional, but I'm going to draw in my fence. This is where we got to divide the playground. We got 2 different functions. This first one, is this going to be on the left side of the fence or on the right side? What does this tell me? Where am I going to put this first one? On the left side, yeah. So on this side, it's going to be the x minus 2 squared, which hopefully you all know is a parabola. On the other side is really easy because that's just a horizontal line. And that'll stay at -3. Okay, so let's go ahead and make our chart. Both start at the 2. So this one, I'm going to start it at 2. And I need to pick numbers less than 2. So can I use 0? Can I use 4? No. So I usually, to keep it simple, I just go in a row. Like why be difficult? 2, 1, 0. So 2 minus 2 is 0. 0 squared is 0. 1 minus 2 is -1. -1 squared is 1. 0 minus 2 is -2. -2 squared is 4. Now, when I put this first point down, is she open or closed? You got to look up here. And why do we know that this first one here is going to be open? Because it's not equal to. So this point and only this first point is open. So I'm going to put an open circle on my fence at 2, 0. And then I'm just going to draw my parabola. It's going to look like half of a smile. And now for this one, this is the best one, because it doesn't matter what we pick, your y is just -3. There is no formula. It's -3. So I'm going to start it at 2 and pick numbers bigger than 2. So can I use 1 and 0 again? No, I'm just going to use 3 and 4. And I don't make a chart for a horizontal line, okay? Normally, if it's -3, I would just go down to the -3, put a closed circle, and just draw a horizontal line. You don't need a chart for a horizontal line. And that's it. That's your piecewise. So your test has everything that was on the quiz, which I'm going to stop now so I can show you all what your quiz will look like. And then it's going to have some piecewise on there. Now, well, I know you already packed up, but can you all copy down the next question? I'm sorry. Copy it down, since we are on a time crunch tomorrow, so that we can just get right to it. So I'm going to have you all copy that down, and then I'm going to call you up so you can see your quizzes.